check, huh? Sure.
Everything good?
Yes.
All right. Let me just grab my second screen. All right. All right, just in time. It's 7 p.m. So let me just do this. All right, so let me just mute everyone else and start the session. Welcome everyone to another edition of Data Sessions. This is brought to you by Singapore Sqlpass. I'm Pio Balistoy, one of your organizers here at Sqlpass in Singapore Sqlpass. So if you're new here, if it's your first time joining us, you can find us on Facebook. This address, SQL UGSG. We post all our events. If you have any questions, if you want to connect and talk about data platform, you can find us on Facebook. You can also find the bigger community of Microsoft user group at Meetup, MSGUG. All our events here in Singapore, from the Azure community, from the data, from the Office community, you can all find it at Meetup. And all our sessions, ever since we started doing this virtually, you can find them on YouTube. If you can go there and join you can subscribe to our channel if you like these kinds of content. And then if you have any questions, any suggestions about our group, about the user community here in Singapore, if, for example, you want to speak in any of our meetups, you can email us, email your organizers, and we'd love to talk to you. Before we go to our session for tonight, let me just invite you to this one. So this Saturday, the Azure group will have an event brunch with Scott Hanselman. Scott Hanselman is one of the famous speakers in Azure community. So we have a brunch with him on Saturday from 12 p.m. to 1 p.m. If you like to talk about how you can develop Linux and Windows applications using WSL, that's the topic for this Saturday. So if you want, you can join the session. You can go to the meetup, to our meetup page, and find the event and more details about the event on the meetup page. For our episode 7, we're still finalizing the date between August 11 and August 18. Watch out for the announcement. We will definitely have 4 more sessions starting August 18, but watch out for the announcement. We got something. We're trying to create something for you. We're planning a trilogy of some sort, a three-part episode. So watch out for the announcement for that. And before we start, let me just remind everyone to please keep yourself on mute while we're having the webinar. If you have any questions, any during any point of the presentation, just use the raise your hand icon on Teams, or you can put your question on the chat. Once we have a logical break during the presentation, or when our speakers notice the chat, then they can answer the question. For those who are joining us on the live stream at Facebook and YouTube, I'll try and read your questions and read your questions to the speakers as I see them. I'm gonna be monitoring the comment section, and then we do have an evaluation after after each of the session. It's just a few minutes. It's just a few minutes survey. If you could. If you could help provide your feedback, or if you have any questions, further questions to our speakers, you can use that as an avenue for it. And then our sessions are being recorded, so it's going to be uploaded later on our YouTube channel. Let me just start the recording for the first one. All right, hello everyone. Our first session for tonight, for episode 6, is about Power BI DAX 101. Our speaker is Aroh Shukla. He's one of the organizers here at Singapore Sqlpass. He's also a Microsoft certified trainer and an active speaker. I think if you've been with us before, you've seen him speak a lot of times here in our meetup. So I'll let him introduce his session and pass it to Aroh.
Hi, Pio. Thanks for the lovely introduction. Okay, so let me share my screen first. Yeah. Hopefully you can see my screen, Pio, right?
Yeah,
okay, great. Yeah. Hello, everyone. My name is Aroh, and today I will talk about something about basic stuff, which is called as Power BI DAX 101. Okay, it's something simple stuff, but a lot of people have confusion. I have talked to a lot of customers, a lot of users. They have some confusion about how do you use DAX. Okay, so I'm not, I can say I'm an expert, but I have done a couple of projects. I want to give some kind of tips and tricks which I've used in my projects. So maybe you can use this particular session as a springboard to learning about DAX. Okay, so this is episode 6, and something about me. I'm a Microsoft certified trainer. I have experience in Office 365, specific SharePoint Online. I have also have some kind of thing for the data. I want to learn about data. So very expertise on than that. I do a lot of trainings in this meetups. Also do some corporate training as well, specifically on the Power BI space. Okay, so I have done a lot of trainings. I do a lot of projects specifically for the Power BI and also for Office 365. If you want to contact me, this is my Twitter handle, and I update my blog very, very regularly. One thing to highlight that everything is recorded, and after the session is recorded, I will upload everything in the meetup, so you can see all my slide deck, all my resources, or my DAX things, formulas. You can check there. So I need to write it down somewhere. You can see everything after the session is over. It's easy and cool. Okay, so goal for this session is pretty simple. Okay, we see what you can achieve with Power BI. Okay, and what is DAX, how you can learn it. I have a lot of people type, how we can learn DAX. It's quite complex. I won't say it's complex, but something you have to learn as a practice, right? So then we see how you can use measures and calculations in DAX. Okay, then it's something which is a lot of people don't talk. It's about something as concept of context. Okay, I am very happy on this thing, because if you don't know about context, you don't know much about Power BI and DAX in general. Okay, then we work on simple stuff. This is a 101 session. It's not a rocket science session. Simple stuff we cover. We talk about simple filters, and we have couple of demos. Okay, so I will show you a basic stuff, one a theory, and I do similar thing on my demo, so that you can actually relate what I'm talking about in my slide deck, how is actually applicable in real life scenarios, so you can actually easily gauge it how it works. Okay, so let me explain what is Power BI. Now, Power BI is there for the last 5 years. Only last week it is finished. It's 5 years in the market, and it is have a lot of tools. Something called as Power BI Desktop, and we have something called as a Power BI Service, which is a cloud service. And third thing is your mobile. So you can use Power BI and your dashboard and reports using your mobile devices. I mostly use a tablet, not mobile, because it has mobile doesn't have much real space. Okay, then again. Microsoft has done lot of BI tools for many years. So you will see that in if you use an Excel and other formula, other things, you have some tools called as Power Pivot, Power Query, Power View, and Power Map. But what happens that these are plugins, and they're not very stable. Okay, so that is the main issue, that Microsoft came with a very stable tool, which is Power BI, which is make life easier for the normal users and also for expert users as well. Okay, so before I go, I just want to tell something about any BI solution. Power BI is only one tool, but if you want to create or produce any data platform solution, you have to go for these particular 4 steps. If you skip any two at any step, whether it's a data model or reports, your solution won't be that nice. Okay, so something called as a loading of data, transform data. Then second step is called as modeling, and third step we're talking about DAX. Today's our scenario, and the last part we're talking about how we can create reports. Okay, I will touch base 90% on DAX, but very important thing which I want to tell you all the people, that if your second part, if your data model is not correct, you can't produce right good calculations. So data model is key for any data model. Okay, and that's why your DAX should be based on their data model. Okay, so very important. I will keep re-emphasize this part again and again. Okay, so what happens that if you create any kind of data which is coming or your Excel table, JSON data from SQL data, the data is not always clean. So you have to do some kind of transformations. Okay, and in Power BI we use a tool called as transform data. Okay, and second step is something called as a data model. So if you know in your college, university, something called as a normalization. So we do normalization in data modeling in Power BI. So we split the tables, make the columns much easier for our reporting. So optimizing tables and column may take at least a couple of weeks or months, depends on your data model. Okay, and then we can segment your data and relationship with different tables. Okay, so that is a very cool and very simple stuff, but you have to do some kind of a brainstorming first. And last step is you have created a data model. Data model is a key for any solution. Okay, so if you see on the right side, you will see a small 3 cubes. That is a data model. Okay, so we will work on that. And today's context. Today we'll talk about the DAX only. So what is DAX? So DAX is something called as a formula language. It's not a compilation as a C#. It's a formula language. If anyone has worked with something called as a Excel use formula languages, right? This is something very simple. Okay, and it's not used for only for Power BI, but other tools like Power Pivot also use DAX calculations. But for our scenario, we use this particular DAX as a primary tool for creating our data model. Okay, and the last one and very important thing is your reports and visuals. So main thing, if your all three things are good, but if your reports and visuals are pathetic, then nobody can listen to your story, right? Because only through visual you can relate a story. Very important. Okay, so never clutter the your data with lot of information. Put a simple information and should be a clear as simple headings for the visuals. Okay, so today is not about about visual, but today is about DAX only. Okay, so this thing will work on this particular sample report. Okay. Okay, again, not today is a simple thing. Again, I want to reemphasize DAX is a formula language. It's not a compile language. It's used by other products. But today, we'll talk, DAX is a primary language to create some kind of formulas. Okay, for us, we have to focus on specific things. Okay, so DAX, if you what is DAX? So DAX is full form is data analysis expressions. Data analysis expressions, DAX in short. Okay, and in DAX you can have those formulas in two different locations. You can create as a calculated columns, or you can do as a measure. Okay, uh, so let me show you what happens. So when you if you use Excel, right, it's quite simple. So in Excel example, you create you create a cell A1 and then B2, add things, you get a result. So in DAX, we also have cell-based kind of calculations. But what is the main power is DAX can do lot of amazing stuff using tables and columns. So for example, I show you how it works, but I can actually sum my entire revenue across a table which is 1 million rows. That is the power of DAX. Okay, that is a thing which we can do. So again, don't worry, I will show all the things in a simplified way. And again, it's a mind shift, because if people are using Excel, right, and then you have to work completely on tables and columns, it's a kind of mind shift. You have to understand the thing. So DAX is simple, but you have to have master it so that you can do your calculations in a simple way. Okay, um, and I think the true power of Power BI is DAX. So if you don't know DAX, you just know only 20% of Power BI. I'm not aggregating the entire thing, but I've seen many people who have in my company as well have done amazing stuff, but he then never used DAX. He create amazing visuals and all, but doesn't give much power. Never use DAX calculations. So it's very important to understand how DAX works. Okay. So again, in 1 hour, I can't show all the things. I pick the most important parts which you can use it as a springboard, the basic stuff. Okay, how you can learn? You can ask Aroh how we can. What's the basic stuff I can to learn DEX? Again, I want to highlight that DEX is simple. Actually, it's quite simple. But only thing you have to do, you have to done have to master it. You have to, for example, you do a cycle, right? You may fall down multiple times, but then after a few days and weeks become master in cycling. Same thing applies to here as well. So you have to do the simple stuff, but you have to, if you master, you have to do repetition multiple times. Okay, and one thing which I have seen many people don't use is something called as a context. Okay, don't worry, I will tell you in my demo what works. But if you know understand the meaning of context, you are all through around the 70%. Really, context is a key thing in Power BI. Okay, and obviously we'll work on the aggregation iterations, how it works, how the calculation works over the tables. So then we'll see how it works. Then there one of the most used a function which is called as a calculates function, which is one of the most important function. It can be used in your simple formulas, but it can be used in very complex scenarios as well. So it does everything, simple formulas to complex scenarios, everything. So it does everything. So one of thing, although this particular session is only for the 101 level 100, but I will show about how you can use calculate. Okay, and again, main thing which a lot of people have a trouble is that you can't audit your formulas. It's no, you can't do any kind of checks there. Okay, so very important thing to highlight that the only thing, if you want to be master, you have to learn only through examples. Okay, you can learn, I want to repeat, if you want to learn DAX, the only way is learning through examples. Otherwise you can't master your DAX formulas. Okay, so again, I want to highlight with any formula language like Excel or Power BI, we have some kind of a different data types and operators. Okay, so in Power BI specifically, you can find data types in two different locations. Two different locations. The first location is your query editor. Okay, first location is query editor. How you can see? You can go to the Power Query Editor, and you see on the second tab, you can see all the different data types. Okay, so this is the way you can find your data types. The another one is using your report view. So in report view, in this screenshot, you can see in the report view, you can see your different data types. And the good thing about report view that you can do some kind of formatting as well. And the so this is the two different places you can find your data types. And for operators, it's just like any Excel formulas we use. We can put minus, plus operators, mod operators. So you can do some kind of simple and complex scenarios. You can do strings operation, other stuff as well. Okay. So today in my demo, I talk about something about calculated columns. So if you have seen this kind of a formula, right, in Excel, you have total cost and multiply by the specific order quantity and total cost is similar thing. Here I'm doing some operator, Excel operator using in Power BI. So we use this kind of formulas in operators in Power BI. So I talk about the data types. Very important to understand the data types. Very important to notice they could be data types which doesn't work for you, so you have to change it. And then the operators. Operator will work fine for you. Depends on your scenarios what you're looking for. Okay. So one thing to highlight that something which a lot of people have confusion about what is a calculated column and what is a measure. So calculated columns works on row by row, okay, in a table, similar what you have seen in Excel. Okay, and if you want to go, for example, if you go to table view, you can see that it has if I go to the data view, go to table views, and you have a column. So in this way you can create a new column. Okay, again in demo I will show you. The other one is you can use it to for example, I want to create a total cost. I can do very simply. Okay, again I show you in demos. Second thing is you can do the entire thing. I show you about calculate columns, but if you want to run some calculation for entire table, then you can use something called as measure, which can run through entire column. Okay, again, how we can do, we can mostly use as an aggregation. For example, I want to create a sum of total cost. So using sum for maybe have a 10,000 rows, I can do very easily, simple. Again, I'm using DAX. So in Power BI, you can do either you can use calculated columns, which add additional columns, or what you can do, you can create a measure. Now, maybe it looks very confusing. Again, don't worry, I'll show in my demo as well. I'm done with one of the slide deck on that. So one thing, very important thing, I just create because I can't find anything which is doesn't make a table. So I found a table. I make myself that what is the difference between calculated columns and measures. So calculated columns works on each row, like Excel, but measures works on a specific context. Again, I tell you context later on. And in data in Excel, we have two different kind of engines. One is a row engine, and second is a filter engines. So calculated columns works on the sumx functions, some kind of similar formulas which we can use, and measures mostly use filter context. So in general, we have two different kind of calculations within Power BI. One is the row engine, and other one is a filter engine. Okay. Other things that he highlight that those values are stored in your data model. So example, you have a data model which is maybe a thousand of rows, maybe million of rows. So it's not a good practice to create calculated columns. But if you create a measure, it will actually help you, because it doesn't work on an actual table. It works on a runtime. Okay, that was a good things about measures. Okay, and we talk about the calculated columns. It works on the mostly on the your computer RAM, but the measures work on the CPU. Depends on the server CPU. So there are two different calculations we can do in the Power BI. Okay, so time for demo. We work on calculated columns. What is the use case and how it works with measures? Okay, so demo one. Okay, so yeah, so this is a one. This is okay. Let me walk through the data set I have. Okay, so I have a data set which has a sales table. Now sales table have a order number. I have the ship date, very multiple round. Actually it's a fact table. It's a transition table. Okay. Then I have another lookup table which is called as regions. So I have regions, all the regions in Auckland and other Northern New Zealand locations I have. Okay. I have another table which called as the product table, which is just calculates number of your products. Then I have date table, which is very crucial for any solution. Date table is very crucial. And the last one is a customer table. Simple formulas, simple data set I'm working on. So this is the my data set, and this is my relationships or that. So this is my fact table. This is my fact table where there's many rows, and these are my lookup columns, right? Lookup tables, which is across my which supporting tables. These are lookup tables. Okay. Last lookout of my example. I want to create a column. I want to do some calculations. So my use case, I want to compute the unit price, the order quantity, and the total unit price for thing. For example, for order number SO 100,153, I want to compute the total unit price. But here I don't have anything to do. I have to do some kind of this data set. I don't have anything. I have to create one more column. Okay, so I have computation of order quantity. Also have a unit price for each column. Okay, so what I will do, I create a calculated column. Calculated column, very important things. So all your DAX calculations typically actually works on your data tab. This is my data tab. Okay, in this data tab, I create a new column. Now you see what's happening, that is showing that write a DAX expression to create a column. Okay, so what for my use case, I will create a new column called as total cost. So let me create a new column. Okay, and this column where I will name it total cost, because in our data set in our sales table we have no sales computation of the total cost, right? So we have to compute. So how I compute, I use my sales order table, and sorry, I use order quantity. Oh no, I'm creating a table here. So no, sorry. I have to create a column. Okay, so here I have to create a column. So this column in this, yeah, I'm creating a column here. So you see that problem is that I have to compute the order quantity and total unit price. How I can do it? Just in Excel, I will just create a total cost, and I will do order quantity or order quantity. Just like Excel, I do operator, which is multiply, and we do total unit cost. Total unit cost. You see now? You see, it takes some time. Now you see, it computes the entire data set, right? It has done the calculation of the order quantity and the unit price for this particular row, but actually it does for entire data set. Just assume now I have around 7,900 rows. Okay, it's not a very big data set, but just assume I give it as a best practice. If you have maybe have a 3 or 4, maybe 5 more calculated columns, and you have thousand maybe 1 million rows, your your size of your data set will be too huge. So calculate columns is okay only for specific use cases where you have your data set is very simple. Okay, so I'm going for that. Okay, so I'm done with that. So what I will do, I just go to this total cost, which is my calculated column. I will see the price here. So this is the price total cost using calculated column. You see, it's a total cost calculated column. Okay, it's a one of the method, but it's not a one of the best method. We can do similar stuff using measures. Let me create a measure for you. Okay, how we can create measure? I want to do same thing. I want to create a same thing, but I'm using DEX calculation. So I will, what I can do, I will go. What I mostly do, right, is my best practice. Just assume that you have 100 tables and you create all your measures in different tables. It's very difficult to track it. It's become always become very messy. So I will always create a measure table inside this key measures. So I can create a measure inside here, or I can create from here. Both ways you can do, but I mostly use because it's very easy to collate all your measures in one simple place. So I create a new measure. What measure? My measure will be total cost, same thing, but here I'll be using a DEX formula. And I will using some kind of aggregation. I will tell you what is aggregation. Okay, and I will do the same thing, but I will do a function called a sum. I'm using a sum function, and asking now it's asking which particular table you want to do. So which our table is a sales table, right? So let's do sales table, and sales table, and the cost will be total cost. So this is our total cost. One second, I just want to check something here. Total cost, yeah. So you see here, so you can get the total cost from here as an aggregator. Okay, so this way you can just do it. So I can go aggregator, I get the same function here. I changed my this thing to aggregator. I get this amount. Okay, so next one, aggregator. So I will want to share something about the aggregator. Okay, so let me go to my slide deck first. Okay, so aggregator, let me show you the aggregator. What is an aggregator? Okay, so before about any aggregation, I want to talk about the context. Context is a lot of people don't talk about context here. So just in layman, what is the meaning of context? Context means you're talking about a specific meaning or a statement. Okay, maybe I'll give you an example. Okay, I'm selling a tea, but give you any context. I'm drinking tea. I'm going to anyways. I don't have a no context because it's very generic, open-ended statement. Okay, so what I will do, I will just I give you context here. Give you context here. Uh, okay, so I give you context here, which is called as just think the daily tea revenue at Starbucks is $10,000. So this one, you give you context, right? If I give you, okay, I'm just selling tea, it doesn't give you any context to you. So here what I'm going to tell you, that I have to give you context. So in Power BI we have a concept of context. Okay, so in Power BI, we can do calculations with dynamic analysis. Again, we can do with a row. Again, we talk about Excel. We can do same thing with columns as well. Okay, so in Power BI, we have something called filter context, which is mostly work as an aggregation, right? Works in aggregation. Okay, the another one is using a row context. Okay, is one as an iteration function. Okay, don't worry, I'll tell you in my demo how it works. Okay, so filter context and row context works in a different ways. Okay, so let me go show you. There are two different engines I told you in my demo as well. So here, when you do calculations, when do any calculation, you run or do different engines. One works on the calculation formula, which is sum functions, filter context engine. Okay, which runs a sum function, which I just showed you in my measure, right? Same thing we can do here. I can do some function here. I create a customer. I can also aggregate. Okay, so what does, right, when you do filtering, right, when you do filtering, so what has happened, I mentioned to you that when you create a new a good strong data model, the filtering will automatically come to you. Okay, so this is a some kind of a waterfall model where all your lookup table, this is a lookup table, and I'm filtering the data for my sales table, which is my transaction table, which is my fact table. Okay, so I can do very simply. So this is the one which is I'm using filter context. Okay, I will tell you in my demo how it works here. The another engine which Power BI works is called as a row engine. The row engine works as an iteration, just like an Excel. Okay, so same thing, we can do the similar thing as a sum. We have done shown you in my demo. You can do similar thing as in the calculated columns, but using the iteration function are much better because it never load your data model. Okay, so let's sum up. So aggregation works for entire row. Okay, it works on the entire row. Okay, so you see the screenshot. If I do total sales, is work on the entire row across your sales table. Okay, and you can do create a revenue for that. This is example. Okay, and iteration function is much better because it never load your data model. Okay, so I always recommend, if people tell me that which is the better approach, always work on the iteration function because it always reduce your data model size and give the same thing which Excel operation have works, right? For example, the operator, I'm doing a simple operator, right? So you can do iteration function using your SumX formulas. So again, sum and SumX formulas are totally different. I give you my demo how it works. Okay. Yeah. So again, I want to tell you again that the re-emphasis that these functions run on the fly. They are stored in your memory or CPU, and it's stored in the memory, so it's much faster. And you can work on the more complex scenarios like if statements, much more easier. Okay, so we can do this thing. So let's work on the the aggregation function and iteration function. Okay, so let me show you how it works. Okay, okay, let me delete this one. Okay, So I create, there is no context. I give you example that this is in Power BI, I have a different methods you can do with no context, with context, or context with different columns. So I give you an example here. I create a new data card here, but did this give any information to you? Does it give any cost and no information to you, right? So it doesn't give much information to you because it doesn't give a much relevant information, right? But if I add to a context, and context means I'm adding this one as a cost. Now you get the aggregation. So in the our context is our product name, and I can add other things as well. I can add other stuff as well, right? I can add new measure. I can add new sales, right? I'm using a sum function. So in my scenario, I will create total cost as an aggregator. Okay. And I will use a sum function. So I want to give you just your hash should be clear that when you click here, you get the intelligence. When you click here, you see some other things, right? You have you have a sum max. So what some function does? What it does, in you will see as the intelligence, it shows that it adds the numbers in a column. Which column? For our total revenue column, right? So let me show you what this one here. In my this sales table, right? This is my total revenue, right? Total revenue. So what is running is running the for each particular order number for customer is getting all the revenue across the table for almost 9,000 rows. So what is this function does? This function does is operates on entire row or column for that particular. So let me go and show you this. And total cost, I would what will do, I put total sales other than total sales, I put aggregator, and I put total sales here. Okay, sum and put total revenue. So what it does, it actually calculates for entire 9,000 rows, right here. Okay, so if I go here, I see I get the entire thing. One is a cost, one is a sale. Okay, same thing, I can do the same thing. Now the it doesn't mean anything because it's no data is there. But if I want to have a context that I want to get the meaning on the number of customers for total sales, then I give the information about entire data. So this is our context here, and I can add more information, but you get all the information here. So aggregation functions works on the filter context. But tell me, Aroh, what is filter context? So filter context, I'll give you an example that again, our filter context, we have a table, right? We have customer table, we have product table, customer table, product table. But how they are related, how they're related together, they're related using our data model. Okay, so for example, if I click on the customer, you see these two rows are highlighted: customer index and customer name index. So I have a relationship between the customer index and sales table, right? Similarly, I have a relationship between the product name index and also the product index. So I have all the columns I can link very easily. That's why it's called as a filter context. You are filtering the information from one place to another, right? That is the using filter context. right? Filter context. Okay. Then we work on another method, something called as and also for aggregation function, we can do other stuff as well. We can create something called as just not sum, we can do average as well, right? I can do average, average sales as an aggregator. Okay. And I also do the same thing. I can just, rather than going to a sum, which we always use, I can do average X. So Power BI have a lot of inbuilt functions where I can do some operations that I can do to sales, total revenue. Put total revenue here. So I get average sales across, right? And also I can create another one for minimal sales. Minimal sales happened using aggregation function. So I can use min sales as an aggregation ag, and then I will do min x. You see, so Power BI dev lot of functions, inbuilt functions, which can also use it. Very simple. You can run on the bin, which is the sum function, and another which is called as a min x, which is a aggregate with the iteration function. So let me do the sales for total revenue. Okay, then what I can do, I can go minimal sales. I can do so, average sales. I make to here. I can also make it minimum sales as well as a data card. Okay, so now I can also do the similar thing. I can put average sales here. I can add minimum sales here as well. Okay, so this gives you a context. So context part is very important because a lot of people don't talk about this thing. But if I have no context, it doesn't give any value to me. You can use as a KPI, obviously, but if you want to get for more meaningful reports, you can use as a context. Okay. Next, we go to something called as a iteration function. Iteration functions. So iteration function is quite simple as well. Nothing rocket science. So let me create another measure, which is for total cost. Total cost. I put ITR. Okay. Okay. And I will use a sum function. Now sum x function. So why when you do sum function, how it operates? Do sum x. Now it show some kind of a intelligence it shows to you. So a table and an expression. Okay, a table and expressions. So sum x actually use two different parameters. So for our table will be always a sales table, right? Sales table. But what expressions? Tell me, Aroh, what expression you have to use? You can use the same expressions which you use in your calculated column, right? Same thing we can do. So in this our total cost, we have one function called as calculated columns. In a table, we have a total cost, right? We can use same function, exactly same function. Right? So what I will do, I will use this measure in my iterative function. I use as sales order quantity, same thing as an Excel, order quantity into operator as a total unit cost. Okay. Okay. Then I put a context here. You see here. But this one doesn't give much value to me, right? No value to me. Main thing, if I add as a customer, I get the value here. So total, for example, I want to compute for each customer, whatever total cost. Now I give you a value to you, right? Very simple stuff. Very simple stuff. Or I can do other stuff as well. I can create other function, some x functions. I can use average x as well. I can use average x. Average cost as an iteration function, ITR. Okay, and I will compute using average x. So average, you see, average works on a number, but average x works on an entire table. So there are two different computations are happening here. One works on a column, but it's a sum. Another one works on the entire table. So this is the main things, again, because you have this recording, so you can just repeat and see how it works. So this is the thing which you can use it. It's a bit complicated at times, but at least you get the basic concepts here. So what I'm doing, I want to actually do some average for specific column. Which column, which particular table? My table is again a sales table, our main table, and I can do a sales quantity, same thing, order quantity into total unit cost, right here. Okay, so I go total unit cost, iteration, you got this thing. You see, so it gives you a much more easier way to understand. I mean, context give you a much more easier way to understand the things. Okay, so again, still have a few minutes left. So for my demo, the last one is I'm going something called as a table function. A table function. Okay, now table function is slightly more advanced, and maybe it's intermediate and advanced concept. But I want to give you a brief on that. So if you want to create a table where you want to, for example, you have 5 tables, but one of the requirement is that you want to create another table from those 5 tables. How I can do it? So you can reshape and create a new table based on your 5 tables. Okay, I give an example here. So assume that you want to create you have this particular channel. This is our sales channel, right? Sales channels. It has a lot of values. It has a distributor. It has a wholesale. But during the COVID time, we have more online and more exporting from different regions, maybe in Singapore or from other places, from US and other places. So a lot of people are exporting and importing stuff from maybe from Lazada, from Alibaba. So more online stuff is happening. So what our use case that we want to create a new table which mostly use the export column. Use the export column under channel. Okay, how we can do it? Very simple stuff. We create a table function using create table function and compute it. Okay, you select a specific column. I will show you how it works in my demo, but I want to show something else as well. I told you that calculate column is one of the most important column you can ever use. So you can use for simple or complex, you can do, but this is all the formulas mostly I use for any projects I use for calculate columns. It's very simple, but only thing you have to do is kind of repetition, to learn from different examples. Okay, so you can do for simple filters, or you can use time intelligence function as well. Okay, it's very thing. So how you can do is you can use an expression. I told you, right? You can use expressions, and you can do filtering as well. So let me. I know it looks more abstract. Let me show you a demo so that you can get the idea. Okay, so let me show you a table function. Okay, so our scenario is that in our during COVID time, a lot of people are doing exporting, and lesser user people are using an export, right? They are either export or online example, right? So the use case is that the users and the management want to create new table based on the export, because export and online are getting more traction from our business in Singapore and other places. So how we can do very simple stuff we can do. What I will do, I again, for any kind of DAX calculations, I mostly go for data tab, and here I create on the table tools, okay, and create a new table. Okay, I create a new table, and this table I will define as a export sales, export sales. Yeah, and I use another DAX function called as filter. I want to filter only people, all the computation about only export columns. So I will do filtering. You see, when you filter, I get some kind of a description. So what it's showing me, filter a table which has to be filtered. So which table? So my table will be always a sales table. So my table is sales table. Okay, and what expression? So expression will be, I will use a sales column because I have to use sales, and I have to use channel because my requirement for the my business, they want to create a new table based on the export column. So I will do export, and that particular f- uh, m- string will be export, export. So very important that and your s- it should be exactly same, right? It should not be small case, small case, and big case. Very important to keep note this about your words, right? Export. Okay. So I filter here. I filter here. Okay. It do some computations. So now see, I get a new table, completely new table called as export sales table, but it's only have export, right? It doesn't have exports. So if I go by my sales table, sales table, my sales table have all three things, right? I have a distributor, I have export and wholesale, but here I have only exports, right? Quite simple stuff, right? So that's the thing. So but I can extend, because this table function, if you have more tables, if your management want to get more tables and all, it becomes very messy. So we can rely on something called as a calculate function. So how calculate function works, so I give you an example. Again, if you want to learn DAX, I have to learn by examples. Okay, so let me show you an example. Okay, so same thing I will do. I want to create same kind of concept, same kinds of concept, but rather than using a new table like export sales, which I show you, it has create a new table here, a new table, right? A new table has created, but I don't need it. I just need on the fly, should on the fly. So my data size is much smaller. So what I can do, I go to table tools, I create a new measure, I create a new measure under this, and I will quote a total export is using method called as a function called as calculate, and calculate expression will be what expressions. Now expression could be uh, your measures. I can use a measure. So what measure I can use? I can use my total cost one. So use total cost. Okay, I use this my one of the function. Okay, and my filter, I use the same filter which I use my table function. So I use same filter function, and I will use table, again sales table, and the expression will be sales So sales and the filter expression will be sales channel equal to export. Okay, done. So if I see here in my calculate function, I will do the I create a table here. I put total sales. This is aggregator, right? Total aggregator for entire thing. Then I can do export sales. Now this will always a short, smaller quantity because we filtered all our export things, right? So this will be much smaller number. You see, it this is a 150 around 153 million. This is only 1 million. But this we are using something called as a calculated function here. Okay, okay. So you see, something happens here because I had nothing. So you can do now. I showed you that you can do exactly same thing for your dashboard also. What I've done, I have used the same functions, calculations, the KPI, and also added lot of my charts, everything, and which all the users can use it. Okay, so this one is my end. It's my end of session, and if you want to know more, I want to share with you that there are a lot of things. I'll be adding more information that you can refer to this particular article about DEX. What is the context is a very important thing, and also some blogs about how the row content works. I'll be adding more details in after I finish session. Some videos which you'll learn, which are very useful because what happens because in cloud you have lot of updates. So videos will be always help you and up the always learning much better because documentation get outdated very fast. Yes.
All right.
So yep. So I'm done with my session. Yeah.
Yeah, all right. Thank you, Aroh. If you have any questions, now is the perfect time to ask them while we switch. Wait, hang on. Let me just. Do we have any questions? We don't have any questions from the chat from the live stream. Sorry about the live stream. We keep on restarting it because of OBS dying on us. But if you have any questions, you can drop them now on the chat.
Yeah, you can ask any questions about that because this the all this DEX 101, but few of the concepts are a bit abstract at times. So I wanted to give you the clear things how you can use it in terms of the DAX aggregator functions, the iteration function, difference between calculation columns and measures. So these are a few new concepts. Maybe I've not used it. It's better to ask them questions if you want to have questions here.
All right. I don't see anything coming up on the chat. If you
Sure.
have any further questions after the session, you can always reach out to Aroh. If you want, if you want, you can use the evaluation to reach out to Aroh to post your question to him. We can share it to him through the forms. The link is also on the chat. And while we won't be taking any breaks since it's already 8, we might as well start with our next session.
Yeah.
All right. So our next session is database scope configuration server settings by Ricken. We've been trying to get Uwe to have a session in one of our meetups since last year, but the schedules never match up. So it's another blessing brought to us by going virtual. We now can have Uwe, even if it's not the F1 season. So Uwe is one of the few Microsoft certified master in Germany. There's only a few in the world actually. So he's also a Microsoft MVP for data platform. He's been doing SQL Server for quite a long time. He's a very seasoned professional. He's been speaking in a lot of SQL Saturdays and conferences. So without much ado, I'll hand it over to Uwe.
Yeah, thank you. So you can hear me?
Yeah, we can hear you.
That's perfect. So let's do a small preparation that I switch over, that I can share my screen.
All right.
Just a second, please. It will work now. Yes. So technique. So come on. Let me. Here we are. So, yeah, and we switch. And that's it. So, okay, so now I share my screen with you. First of all, big welcome to everybody. I know that it's late evening in Singapore, I think. It's 8 p.m., right?
Yep.
So in Germany, it's currently 2 p.m. So I'm awake, completely awake. So I hope that you can see everything here. You can see my screen, that you can see my presentation.
Yeah, we can see your screen.
Perfect. And I hope that everybody could read this, that the letters are large enough for you when I show you my SQL Server Management Studio. Is that okay for you too, yeah?
Yeah, we can read it.
Okay, then we can start. So first of all, please feel free to ask any questions after the session. I'm very happy to answer every single question from you. To be honest, I would have loved to be on-prem in Singapore, but unfortunately this year I cannot make it happen because of the restrictions of COVID. So I think everybody can understand it so far. And however, thank you very much to the organizers. It's a really great pleasure to speak for the Singapore user groups. It's always a pleasure for me being in Singapore. And my topic today is database scope configuration. I want to give you unfortunately, a short overview about the functionality of it and the reason behind that. So this is me. This is just only commercials. Forget about everything what's on the left side. Just only take a look to my email address. It's a true address. It's not a fake address. Whenever you have a question or you want to have a slides or the demos, whatever you want, some recommendation, drop me an email. I promise to answer you every single email, hopefully in near time. So this is our topic. We are talking about database scope configuration. And a database scope configuration, first question what came up is, what is it? What is database scope configuration, and what configuration items are available? So what we want to handle, what I want to show you is, in this session, just only the server setting database scope configuration, because we just only have 1 hour for this. Before SQL Server 2016, configuration options were only be available on a server level. And the biggest problem with that is whenever you change one setting, it could lead to problems for databases. Let's say you have a hosted instance where you have, let's say, 20 database application databases. And if you set one server configuration setting, it affects all the 20 applications. And that could be a nightmare. For Microsoft, it was a pretty cool deal, because for just only one reason. If you see that you, for example, change the max degree of parallelism, and then one application could not work with that, what do you have to do? You have to implement or have to install a new instance or a new SQL Server. And that means licensing, that means dollars for Microsoft. One of the most known products, I think most of you know it, is SharePoint. When you want to install SharePoint on a server, it requires that the max degree of parallelism setting is set to 1. And if it's set to 1, it does mean that it affects every single application. So just for example, you have your SharePoint and you share the instance with a high transactional system. That doesn't work for you because the max.1 does affect the high transactional system in the same way as it affects SharePoint. And that problem, Microsoft became aware of very, very quick. And excuse me, maybe you remember long, very, very long time ago when Azure came into the game, SQL Server database as a service. Then Microsoft was thinking about the database scope configurations. So with the possibility of the configuration of database scoped items, we can now implement a more granular setting based on single databases. And that makes it absolutely perfect. Database scope configuration can be configured different for an always-on availability group. And that is one of, to be honest, one of the biggest, coolest thing. Think about, again, about the max degree of parallelism, or better, the coast threshold for parallelism, oh, max stop, sorry. The max stop is for an OLTP system. Let's say a max stop of 4 is absolutely perfect. But what will happen if you have an always-on availability group, a secondary, a readable secondary, where all your reports are going on? Then it might be very cool to have a max stop of 8 or 16, something like that. And with database scope configuration, you have this opportunity to set the settings on the readable secondary different from the primary server. And that is a really cool thing. Database scope configuration, as the name said, is based on databases, not anymore on servers. And what you see here, and these are the 5 topics I want to show you, is the most popular settings. Max degree of parallelism. I know that most of you know what max degree of parallelism does mean. And I want to show you how it will be set on database level. Parameter sniffing is a big, big issue. Parameter sniffing, if you can disable it on server level, but the problem is if you do it on server level, every application is affected. Optimize for ad hoc workloads, very cool thing, not so often used. But the 4th point, that is a quite interesting thing, and to be honest, you need, so when I show you the demos about the identity cache, you need to have a little bit experience about the internals of SQL Server, but don't worry, I try to explain it in a very easy way. And the last but not least thing is the cardinal estimation. You know that cardinal estimation, the new cardinal estimator with SQL 2014 came into the game, and everybody's saying, yeah, fantastic, yeah, my ascending key problem is solved, blah, blah, blah. And a group of people said, oh my goodness, my queries are running slower than before. And this problem can be changed with the cardinal estimation. So that is the point I want to show you here. So the general configuration item is so that we have the max degree of parallelism, parameter sniffing, optimized for ad hoc workloads, identity cache, and the cardinal estimation, which could be configured on server level only. Now we can do that on a database level. Here comes the first thing, the max degree of parallelism. Long story short, the max degree of parallelism determines how many cores can your query use when it goes in a parallel mode. That means that the costs are quite high, and when the costs increase, then SQL Server will decide whether to use a parallel plan, and then it consumes all the cores which are available, which has been set to the max degree of parallelism. The commands for every database scope configuration is quite simple. Alter database scope configuration, set name of the configuration parameter to a value. It will be overwritten by a query hint. I think that a few of you know what it means. When you enter a query, when you run a query, select star from, and you use the option max stop, that will overwrite this, and that is the same as with the server configuration. But here comes the good point. It will not be overwritten of more restrictive server configuration settings. That is a cool thing. Think about SharePoint again. And again, think about the situation that you say, I have my SharePoint databases on an instance, and I have my OLTP system or my data warehouse system on the same instance because I want to save money. And what you can do then is, let's run on the server side the max stop 1 for your SharePoint, but for your data warehouse, you can configure the max stop dedicated to your database, and that will be used over a server setting, whether it is more restrictive or more open. It doesn't depend on the database scope configuration rules over the server configuration. And I want to show you how that does work. Very simple, easy query. I have prepared a database, and what I'm doing is very primitive. I create a view By the way, the table, I have here the tables, they are all heaps, so that means I don't have any optimization with indexes. So what I'm doing now is I configure my SQL server setting to the defaults. So the cost threshold for parallelism by default is 5. It's way too less, but that's the default. And the max degree of parallelism in line 69 is set to 0. That means when my SQL server, when my query runs, it will use all my cores. Not a good practice, but seen very, very often. So now I'm in my customer orders, and I set the database scope configuration to 02. And here comes the query. Go for it. It takes a while. There's a few rows in. So, and here we are, and we have 4 seconds for 129 rows. So when I look into the execution plan, you see here, what a nightmare. Everything is going in parallel. And the good thing or the bad thing with parallelism is whether you decide, is the distribution of data okay or is it not? When I look to the customers, just want to show you what I mean. Here, when a table scan is coming into place, you see the number 10. And here you see a really, really bad plan for distributed data for a parallel plan. You see that only just one core is doing the work, but all the other 3 are doing nothing. And that is a bad thing for parallelism. If I look to the order, to the customer orders, that is okay so far, because you see here that SQL Server has distributed the data evenly on every core. So that is the point. And if you want to fix that, what can you do? We have here our IOs, lots of data, lots of IOs. And the biggest problem is here, when I say that the max stop is 0, it does mean take all my cores. And now think big. What will happen when you go for a query or go with an application, let's say with 1,000 clients running all the same query? That takes way too much time and all the CPUs gets consumed. So you decide then to say, okay, on my SQL Server itself, we have a max degree for take all my cores, but in this database, I don't want to have it. So I change the database scope configuration to max stop 1, and I run exactly the same query. And I think that you all know what will happen now. The query will run now in exactly the same time. That's okay. But here you see that the query is running never again in parallel. Also, the query estimated cost is 147. That is way, way, way too high for single-threaded processes. But we have configured it. But what the developers can do, so if any developer is here in this as an attendee, do not do that in production. If you can, let's say you have a big query and you find it quite annoying that the DBA is restricting your power of the SQL Server. However, what you can do is run an option max stop, and then it will run in parallel again. And that is a behavior, what SQL Server is doing, whether it is on a database scope configuration or it is on a server configuration. If you put a hint in your query, it will always overrule the setting of the server or the database. So, by the way, we don't go to it, but what I can say, I make long story short, if you have a snapshot of a database, I have lots of customers who are using snapshots for reading data to put a few information. They want to have a snapshot and then they read the reports from there. The rules will be exactly the same. So when I change it to 2, doesn't worry. So when I put it to 2, run the query again. So now it does mean that SQL Server is only allowed to use 2 cores and it will work perfectly. You see here, thread 1, thread 2. This is the consumer thread. So, but what will happen now? I put it to 2, and now someone is changing the server-wide configuration to 1. So that does mean that we now have a more restrictive setting on the server. And my first expectation when I was reading first about server configuration and database scope configuration was that the server will rule over the database, but it won't. So the database setting is always the leading setting in your database. So this is another database scope configuration. Do that not in production. You see what the system will do. We clear everything. Every execution plan from the database gets cleared. And I run it again, put it on a 0. And when I run it again, we will again use, maybe people may think 4, but the server configuration now comes into the game. Because the 0 does mean if you put the max stop to 0 for database scope configuration, the expectation for a customer was when they put it to max stop 0, then it takes all my cores. No. When you put it to 0, then the server setting comes into the game again, and that will limit the parallelism of the query. So that we can skip this. Yeah, fine. Okay, so far that was about the max degree of parallelism. If you have any question, as I said, feel free to ask after this. Parameter sniffing. A parameter sniffing problem is, I would say, nearby in every database I have seen with a customer. That is a really, really common problem if you have skewed data in your table. For example, you're running a business in Singapore, and most of your businesses are doing in the Asian area. Suddenly, a tiny little company from Germany is coming and is ordering something from you. Let's say you have 1 million rows into your order table, and then you have a stored procedure which filters your data based on the location. What will happen if you run this stored procedure, run it against Germany, then SQL Server will see, oh, come on, it's just only 1 row. And one of the biggest problems is if you run it again, then afterwards, again, the Asian area, then it's say, well, we have 1 million rows. But the problem is that the execution plan has been generated based on the very low number of rows for the German rows. So, and that is a problem. What you can, or maybe can solve with disabling parameter sniffing. It is not a common approach, but it is possible to do that. Before using database scope configuration, the DBA could use the trace flag 4136. That was a common thing how to solve this. What does this mean? Very, very simple. I will show it in a demo later on. It does mean that SQL Server will not sniff the value and reuse it for the compilation of the execution plan for the second, third, fourth run of the query. The biggest problem with this trace flag is, or was, it was server-wide. And again, we have the same problem as we have with the max stop. So it was not a very useful thing. But what you could do was, you could use it in a session as a trace flag. That means, for example, you run your store procedure and then you enable the trace flag just only for your session. Here come the biggest problems. To do that, you need to be a sysadmin. So it was absolutely a really weak solution. But then SQL Server with 2012 came with query hints. And I think that most of you know the query hint optimize for unknown. And optimize for unknown, that is exactly the same as disabling parameter sniffing. I will show it in the demo and explain it in the demo. Another option, but that is handling exactly the same situation, is setting a query trace flag. The query trace flag 4136 does mean that you do not enable the trace flag on a server or session level, but only on a query level. But again, we have a problem with that query trace on blah blah, because you can only use it if you're sysadmin, because you're changing configuration settings. And again, that wasn't feasible, so that was the reason why we have the optimize for unknown. A third practice is using a parameter inside a procedure. But that is all, let's say, too abstract, because I think we could best learn when we see how it works. And here comes the story. We go back to that, and we go to the properties, and we go to the parameter sniffing topic. So what will I do? First of all, I create a demo database. And what I'm doing then is I put a few records into a table called dbo.messages. So these are, I have a 2019 server running, and in 2019, this means we have around 300,000 Aroh messages in our sys messages. Every single edition of a new version of SQL Server is creating more and more messages. So now what we have is, let me show you what it is. When I look to this, it looks great. Here we have, these are my warnings, messages, error messages, all this kind of stuff. And you see that we have around 310,000 rows. So your developers say, well, it is not allowed to access the table directly. Give the application a store procedure which will be used to gather the messages. And here is my store procedure. And you see here that I have created on the severity an index. And this severity is the parameter for my stored procedure. And what I'm doing here is I want to see all my messages based on a fixed, on a severity value. Here comes my result. Think about the story with the shop. And let's say there is a few people coming from Germany. Most of the people are coming from Asia. And here comes the problem. I run the first one, get messages, severity equal 12. So that you see here, my severity is 12, and have a look to the number of rows. It's only 22, pretty cool. But the biggest problem is when now we come to a problem or to a number where we have more of them. Let's have a look to the execution plan. And that is really interesting. Please draw your attention to the sort operator, please. I have in my query, sorry, here we are, an order by message and language ID. Due to the fact that it's not indexed, we need to have a sort operator where all the rows, these 22 rows, are going through, and then we go to a sort and give to the output. Have a look to the following information. First, look to the estimated subtree costs. It's 0.08, but a stop operator, like the sort operator is, requires memory, which means we go, SQL Server, before it runs a query, is going to the OS and say, hey, come on, I need 1 megabyte of RAM. And the OS system is asking for, what do you need this? And SQL Server is answering, well, I need to sort something. And then Windows say, well, okay, baby, here you have it. So we now have requested 1 megabyte. And you know, I think everybody of you know, plan reusability is one of the preferred techniques in SQL Server or in any RDBMS. But reusability of an execution plan does mean that when we say, hey, come on, it's exactly the same query, that then SQL Server decide, well, okay, I have a plan for you, and see what happens. I run this query and it runs, and it takes a while. And we have 4 seconds for 227,000 rows. To be honest, I know a few developers who would say, oh my goodness, it's amazing, incredible fast. The reason why they say it is they compare, say, well, come on, 200,000 rows in 4 seconds. That's brilliant. The problem is that the developers do not see the execution plan. Click on it. Oh my goodness. You see here, first of all, that we have exactly the same execution plan. SQL Server is going through the index, and then we have to take a lookup in the heap to get the rest of the rows. And look to this. When you see the number of rows, the actual number of rows, which with 227,000, have a look to the estimated number of rows per execution. The estimated number of rows is coming from the very first execution of the store procedure. And what you see now, hopefully, what problem we have, because SQL Server was thinking that we were coming back with 22 rows, and therefore SQL Server say, come on, I need 1 megabyte of RAM for the sort operation. But I think that you know that this could not work, because with 1 megabyte, I am not able to sort 227,000 rows. So we run into a problem. And this problem does mean that SQL Server was using tempdb for the sort operation. By the way, you have a best practice SQL Server configuration if you have your tempdb on the C drive formatted with a 4K and just only one file for tempdb. Enjoy it. And if you have a proper installed tempdb on a flash disk, for example, and you see that your query is running slow, what will you do? There is no faster storage than flash disks. Yeah? And if you see that the SQL Server is running slow, keep your eye on the execution plan and see what's going on here. You see, oh my goodness, we have a sort spill. And the reason for that is very, very simple. Let me show you the problem. If I look to the SQL Server here, so what you can see here is, let's go for the parameter list. Here we have a common scenario, what we all want to have. It's called parameter sniffing. Look to this. The execution plan is based, or has been created, based on a value of 12. Due to the fact that the query didn't change, the query code didn't change, nothing changed, SQL Server said, well, okay, it's exactly the same query. Why should I change the strategy to retrieve the data? But unfortunately, you see, well, this plan is for the number 12, but I used it for the number 16. And that is a problem with skewed data. So what I'm doing now is, vice versa, I clear my data cache. So I run it with the 16, see what happens. 4 seconds was the time. It will be here nearby the same, but that's because of the output, okay? But look to this. Bang. What SQL Server did was, SQL Server was running a table scan with a sort operation, which was the most expensive part here, because we see that SQL Server is saying, well, it's the 227,000 rows, but look to this. Look to the memory grant and compare it to 1 megabyte. If I could have this as Singapore dollars, I would live in Singapore with the beginning of the next month. I would buy a house, a door of a house. Singapore is quite expensive. So, and then what will happen? That was the very first query, and now I come with this tiny little rows with just only 22 rows. Look to this. Incredible fast. And think about the developers. They would say, oh my goodness, it's less than a second. But what is the drawback? Look to this. SQL Server was running a sort operation, which is fine, but look here what happened. The estimated number was quite high, but the actual number is very slow. But think about the memory allocation. What you see here is a dedicated thing coming from SQL 2019, this adaptive query tuning. It's a part of the intelligent query processing. I don't want to go into detail to that, but the memory grant gets adjusted dynamically. So, but the problem here again is we have just 1 megabyte to use, but SQL Server has requested 99 megs. And again, don't think or don't have a look just only to this single one query. Think about a web platform, and thousands of people are running this query at at same time. Then you will run into trouble because the memory will not be enough, and you will wait for memory and the queries will not execute. And that is the nightmare. So what we did before the database scope setting, we could disable this parameter sniffing by using the trace flag. I execute this. So now for the whole server, parameter sniffing is disabled. Don't do this in production. You will definitely run into trouble with your managers. So here we have the, just a second, let me check this. Yeah, the DBO get messages. My query has been executed 2 times, which is perfect so far. And you see that when you set this trace flag, the cache won't get deleted. It will not clear the cache. Run it again with the 16. Run it again with the 12. That, by the way, is absolutely another problem. So many people think, well, come on, give it a trace flag and everything gets new. No, we now have 4 executions. So what you have to do is, when you want to use it, get rid of the old plans by clearing the procedure cache based on this database. So once again, I go with severity 16. And so unfortunately, I don't see you in front of me, because otherwise I would ask you, would you say that now everything is fine? We are in a pretty cool world. And a few of the attendees, when I do it, this session on-prem, they take, well, yeah, sure. Because parameter sniffing is evil. So many people are telling that. But have a look to this. I run it with the 16. Riddle. And the really interesting thing here is you might say, well, okay, it's pretty cool, but it isn't. Look to this. The problem is that we have, again, a sorting problem. Before I show you what the problem is, let's look to the memory grant. And you see that it is now 56 megabytes memory grant. Have a look to the estimated number of rows. Oh my goodness. With a 16, the store procedure, before we disabled parameter sniffing, it was way more accurate. Now it's telling me that we have around about 20,000 rows only. Where does it come from? Let's see what it's doing with the number 12, 22, and bang. Oh my goodness, again, now we don't have the information at the sort operator, we have it on the select operator, and SQL Server will tell you, well, come on, baby, you are using too much memory. You have 17 megabytes of memory, which I have requested for you, and this is only for 22 rows. Are you kidding? And the biggest problem here is that SQL Server is, again, estimating around 20,000 numbers of rows. Oh my goodness, what's going on here? Let's see how often we have executed it. Perfect. The biggest question what's come into game is, where do these estimates come from? And long story short, what SQL Server is doing is SQL Server is not looking in the histogram of the index, but it is using the so-called density vector. And the density vector is a distribution, an even distribution of all available values over the whole number of rows. So what you see here is an average per severity, and that is the point. And if you disable parameter sniffing globally, that does mean that every single database is affected, every single query is affected. So therefore, what you should do then is, you should use, if you want to do that, by using the database scoped configuration. You can use it in this way, like that, that's for session, or you say alt database scope configuration. Now I have to think, it's parameter sniffing equal to off. So hopefully it was okay. Let's see. Yeah. Sorry. The equal to. That is something which is very funny with Microsoft. Sometimes you have to use an equal, sometimes not. Oh, I have to check it. I do it this way. Okay, so now I have it just only here in my session, but not on the server. But this is only allowed for this admins. So, and that is not a good thing. So switch it off. Instead of using the database code configuration for parameter sniffing, what you can do is, let's say you have an older version of SQL Server which does not support it. Don't worry. Here is the trick. You can use it in your query, then you avoid it. Or what you can do is you use a hint called disable parameter sniffing. This is one point. Or what you can do is you're using a variable. And to be honest, normally I would ask for everybody here in the room who is using variables in store procedures to use them as a predicate in a select statement or an insert or what else in a select statement. If you do so, it is not good if you don't have problems with parameter sniffing. Because if you do it this way, you declare a variable and then you use this variable which you have formally declared in your store procedure, then SQL Server is not able to use the histogram. It will always use the density vector, and that means that you only have an average of numbers. That is not the good thing. Oh, here it is. Yeah. Set parameter sniffing on off. And I think that we are, what is the time? Yeah, I check it out later on. The good thing is I'm the last one, so I can extend my session as long as I want. But hopefully you will enjoy it so far. So parameter sniffing is a problem in databases. I see it quite often. And to be honest, also you have this option for parameter sniffing for databases. I would not recommend to use this. If you have some problems for that, my opinion is use the optimize for unknown or disable parameter sniffing as a query hint, because that is the most granular thing to avoid that. Optimize for ad hoc workloads. That is another interesting thing, and to be honest, this will mostly happen if you have applications, vendor-driven applications, where you cannot change the codes. One of the biggest problems is when SQL Server is storing an execution plan, then this execution plan consumes memory. And what you want to do is you want to use your memory not only for cached plans, you want to have it for the buffer pool and want to have it for your data. But the problem is that SQL Server can, the application, if it's wrong, if it's not correctly developed, can absolutely bloat it. That means that you have thousands of plans in your plan cache, but every single plan is only just used once. And believe me, you can see it very, very often in applications. Let me show you what I mean with this. No, so go for it. Optimize for ad hoc workloads. Again, I'm using my customer database. It's a 700 megs database. And what I'm doing is I am creating a unique clustered index on the customers table, because what I want to do now is I want to run 100 queries against my customers. First of all, what I'm looking for is, hey, how many execution plans do I have which are depending on the customers table? And I have nothing. Okay, and now I play around with the application, with the code which is hitting my database. And please have a look to this one here. So what will I do? In the row number 62, you will see my statement. It's called select star from customers where ID is equal to a placeholder. And then what I'm doing is I'm replacing the placeholder with the current value of the I variable. So what does this mean? When I run it for 100 times, SQL Server will run a statement called select star from customers where ID is equal 1, ID is equal 2, equal 3, 4, 5. And as I said, believe me, there are lots of applications on the market who are doing this. I run this. Yippee-yay, you will see now 100 executions. And now have a look to my execution plans. And I think that you all will know now what happens. We have 100 execution plans. 100. Let me drop this, put it to this side here. Okay, look to this. We have 100 rows, and this is a very simple query. It's nothing complicated, but look to this. This execution plan consumes 16 kilobytes, and we have 100 of it. And this is in less than 2 seconds. So now think about an application which is running thousands of these queries against your database, and every single time with a different ID. The problem for SQL Server is when you change a small text part in your query, then SQL Server will automatically generate a new plan. Why is SQL Server doing that? Well, what SQL Server is doing here is SQL Server is creating a so-called query hash value from the statement, so from the text. So for every single change, let's say you have a space in between, you have another predicate, then the query hash value changes, and that leads SQL Server to generate a new execution plan. And that is one of the biggest problems. So what I'm doing then is I say to SQL Server, hey, please optimize for ad hoc workloads. Optimize for ad hoc workloads, do a significant different behavior, significant different behavior. You see here is exactly my same query. Go for it, 100 queries. And when it's got executed, and then I have a look to the execution plans, a few of the people normally would say, well, okay, I just only have one, but you don't have, you have 100. 100 execution plans, but to be honest, it's not really an execution plan, it's the so-called plan stub. Look to the batch in size. The batch in size is 136 bytes only. And now you might think, hey, come on, that will solve all our memory pressure problems. It won't. Think about an architect. And let's say you are the query. You go to the architect and say to the architect, hey, come on, I want to have a house. And the architect is doing a plan for you. In this scenario, what you see here now with the ad hoc queries on is the architect will hand over the original plan to you. Now you go for and execute it. So you build your lovely, wonderful house. What will happen if you go the second time to the architect? The problem is that the architect don't have a plan for you. Also, you want to have exactly the same house. The architect needs to redesign it and needs to recalculate it. And that does mean for you and for your server that you will increase for the second run the CPU consumption. Here is the query again. The only difference here is I have a step number of 10. So I don't go for every single query again. I just only go for the 1, the 11, and so on. Go for it. It's just only 10 queries. And now compare these 10 queries to the rest. And you see what happens. It's again the big plan. And the reason for that is that SQL Server or the architect is thinking as follows. He said, well, Uwe was coming to me the first time he wanted to have a house. I planned it for him. Okay, I thought he will only come once, so I gave him the original plan. Then Uwe came again and said, hey, come on, I want to have exactly the same house. But now the architect is not as stupid as before and said, oh my goodness, it could be that Uwe will come a third or fourth or fifth time. And for that reason, the architect decides with the second run of the query, I want to have a plan in my plan cache. And that means for SQL Server that it now stores the full plan in the plan cache. When the query is running the very first time, it only stores a plan stub, which is an information for the architect, well, Uwe was here. And if you run exactly the same query for a second time, then the architect decides, well, okay, now you only get a copy of it, and I have the original plan with me. For the architect, it does mean when you come to for the second time, your CPU will increase because the second time SQL Server has to create the plan again. For the third time, not. Look to the use counts. Here you can see it. Here is the plan stub. It said, well, it was executed just once, but the full execution plan, the full use count for a fully designed execution plan is on 1, 2, because it say, well, now this is the very first time I gave the client the copy of the plan. And if I would run it again, then I have a use count of 2, 3, 4, and so on. So that is definitely a problem here with ad hoc workloads. The Americans have a good synonym for that. They say there is no lunch for free. And that is your role as a DBA. You have to balance the settings. If you say, okay, come on, if I change this one, what effect will it have? And if I change it back, what effect will it have? So that's a balance what you as a DBA have to do every single day. When you change the database scope configuration for optimized for ad hoc workloads, keep in mind that the existing plans get flushed because they got irrelevant for the system anymore. So let's see what time it is, because I want to show you the absolute amazing, feature of the identity cache. And this is something, I have 10 more minutes. Oh, that's cool. Good. Identity cache. Maybe a few of you have heard about or have read in blogs or have faced the same problem like the following. You run your SQL Server 2012, you came from 2008, and you have lots of tables with an identity column at the first column where a primary key is on. And maybe you have heard or have read in the internet that a few people were complaining about the situation that with 2012, their identity values after every single reboot of the machine was jumping for 1,000. So that was a big problem, or to be honest, I'm wondering why it should be a problem, but the people were complaining about it, say, my goodness, no, I want to have after the 1 a 2 and not a 1001. So this jump was because SQL Server or Microsoft has used the so-called identity cache with SQL Server up from SQL 2012. What does this mean? When the database is coming up, then SQL Server in the phase of loading the database after a restart, SQL Server is going through all the identity columns and is caching the next 1,000 values. So then what will happen, whenever you want to insert a new row into the table, SQL Server was not using anymore the system table. I will demonstrate it to you how it worked before and how it works now. And SQL Server was not running into contention on the system objects. So because we had it in the cache that is in memory, and SQL Server was throwing the numbers away to the processes, 1, 2, 3, 4, and very, very quick. But the problem is, excuse me, the problem is when the server restarted, then SQL Server had to grab the next 1,000 identity values to put it into the cache. And that is the reason, or that was the reason, or is the reason, sorry, that we had these jumping numbers in the identity values. So Microsoft did listen to the customers and said, okay, well, if you want to have this very slow old behavior, then use the trace flag 272, because then the data will be grabbed directly from system tables, but we do not recommend that. The problem is that this trace flag again is on server level. So if you disable the identity caching on the server level, it will affect every single database, and this is something that we don't want to have. So therefore, Microsoft said, okay, this is a functionality. What we want to have inside of a database as a database setting, as a database scope configuration. And let me show you how this worked. It's amazing, but I want to warn you, we go a little bit, we go very deep into the internals of SQL Server. Maybe a few of you are clapping their hands and say, yeah, my goodness, we have a 500 or 400 session here. No, this is only for understanding what the problem is. And I try to keep it very, very, very simple. So here we go. What I'm doing is I create my demo database, and what I'm doing is I am now changing the behavior on a server setting, on a server-wide setting. I now will do SQL Server use the old version, how it worked before 2012. Go into my demo table, go for it, and here I create my customer table, make a checkpoint because I don't want to see anything in the log file. Let's just have a look for it. Looks brilliant. Okay, so that was the starting. You see here that I have an ID, which is an identity. And what I'm doing is now I'm inserting a new row. I put it into a transaction to see the open blocked objects. As long as my transaction is open, and here is my insert statement. Go for it. So we are in flight, we are in a transaction, we have inserted a row, and my first question is, what resources are blocked by this insert statement? And look to this. That is interesting. Here is my customers, my object, this is my table. In this table, on the page 142, IX does mean, hey, we are planning to have an exclusive lock in the object on the page on this value. This is my key value. This is my record. So these three rows, what you see here, are all only relevant to the customers table. But look to this. You see here that a system table, Sqlpass, is blocked. Oh my goodness. There must be something interesting. The first question what came up was, my goodness, for what is it good for? We come later on to it. When I look into the log record, we go down and down. This is not so interesting here. Look to this. Here is the Sqlpass. You see this here? Again. So what is SQL Server doing here? The rest inside here is building up the table, and here is my insert row. So here gets my data inserted, but think about the logical order of work. When we run this insert, first of all, the very, very first thing, what SQL Server has to do is we need to grab an identity value, a new identity value. And this is in my log records here, the very first thing. Let me check where it is. Here. What SQL Server was doing is SQL Server say, come on, I need a number. So the very first identity value I get is the number 1. Okay, so what SQL Server was doing, we are grabbing a number, then we create the table because it has not been created physically, and then we insert the row. So let's check it out. And keep in mind that this Sqlpass has been blocked. So the first very cool thing now is we are all people who want to investigate. Hey, what's going on there? And you maybe want to know what is in this Sqlpass. If you try to run a select against it, you will fail, because the problem is that this Sqlpass is not available when you're not in the admin mode. So what you see here, and this is what I will do quite often now, is we need to connect to, we have to change our connection to a so-called admin connection. Only with an admin connection, we are able to get a view into this column. into this table. So what I'm doing is I'm changing into the SQL command mode. And now what I'm doing is I connect to my machine with an admin access, administrative connection, and see what's going on here. Ooh, cool. You see here now that the system, that this tables, this Sqlpass is storing all my columns which I have in my table, and the for us most interesting is this one here. And this one is the identity value, which is the currently used identity value. I need to convert it to a, because we only are interested in the first 4 digits, and this is my value. And you see this hex value, if you convert it to a decimal, you will get the value 1, yeah, because we shifted, and then 0, 1 is 1. I hope it's not too complicated. So what I'm doing is now I'm inserting the second one, and see what's happening now. It's 2. So what SQL Server is doing in the old version before 2012 is SQL Server is tracking the actual identity number in a table. It's tracking it in a table, and when we track it in a table and we need to update this table and we're in a transaction, I think that everybody of you can understand what problem it could cause if we have hundreds of thousands of processes which are hitting permanently this table and wants to insert new rows. So in 2008, it was really a problem. We got a contention on this table because lots of requests were waiting for this one. And I want to show you a very, very cool thing later on. Let me check this. The biggest, one more problem, by the way, but I know that you know it. If you start a transaction, begin transaction, and you insert a new row, you think about that we are now at the ID number 3, and you roll it back, this number is lost. Why? Well, SQL Server is tracking it and say, come on, there was someone who was grabbing the number 3. For me, it is not interesting whether it was successful or not. The number 3 is now out of the game. And that is one of the points where some developers get nervous, say, oh my goodness, I'm missing a number, and they want to have it again. And that's the reason why they try to reseed, so they change it, try to adjust the identity, all this funny kind of stuff. Don't do this. So what I'm doing now is I want to show you a very, very interesting effect. What I'm doing now is with the old version, by the way, with the old version is I want to show you what effect it has when you run this for, let's say, what I'm doing is I'm now hitting for 30 seconds permanently the table. And therefore, what I'm doing is here I'm creating, or here I've prepared it, I create an event session called db log this Sqlpass. Here we have it. And I'm just only tracking the database ID 6, which is my demo DB. And the resource 41 is the ID, the object ID of this Sqlpass, and it's from type table. And I'm only putting it into a histogram. A histogram does mean that we have aggregations on it. I start the session. I open the histogram. Oh, I love this. Refresh interval is 5 seconds. So now every 5 seconds, we get an update whenever we are accessing this Sqlpass. And now I have another interesting tool for you. Maybe you are interested in, maybe a few of you have heard about SQL Test. SQL Test is a great tool from a good friend of mine. He's living in Munich, Ramesh Mayapan. Maybe a few of you know him. And what you can do with this tool, you can use you can run with 16 workloads at the same time, and hitting your SQL Server. Best would be to do it in a development environment to see whether your application is working or can scale. So what I'm doing here is I have my workload number 1, and you see that I go into my demo DB, with the integrated security, and I only run this query, insert into customers, first name, last name, A, B, A, B, A, B, and I want to run it for 30 seconds. So clear the result, clear all tabs. So what I'm doing here is I run it for 30 seconds with just only one thread. So that means just only one process is hitting it. So I try to, that you can see both. Here you have the value will be 41 because that is the ID of the table. And here with the count, you will see when I start this process, every single time when I hit the table, then it will be increased. So start the current and see what's going on. And you see now here are my threads are running, and it's doing it now for 30 seconds. And you see here, the duration is 8, 9, 10 seconds. See what the counter is doing. It's growing. So whenever a new record gets inserted into the table, SQL Server has to grab a number, and therefore it needs to access the Sqlpass table. And that is so annoying slow because I'm not doing it with only with multiple sessions. I'm just only doing it with one. And see, we have 9,555 rows inserted. And look to this. It is nearby the same. Oh my goodness, you will say. Oh, so that, but that is the evidence that whenever you insert a new row, SQL Server has to go to the Sqlpass table and grab a number. So let's go. I truncate the table. Hey, this is okay. It's empty. So I restart it. See what's going on. Here everything is fine. And where is my statement? Hey, oh come on, mama, who is this? I'm looking, sorry, here. So now what I'm doing is I'm using the database scoped. I'm doing it globally here, but I can do it with the database scoped configuration. I now enable the functionality again that we retrieve the data from the cache. Go back to the histogram. Come on. 5 seconds and run it again. And see what's going on. Look to the counter. It's growing. That's okay. But only whenever we have hit the range of 1,000, then it's grabbing the next 1,000, the next 1,000. And you remember how many rows we had inserted, and now see how many rows we now can insert. You see that the number of iterations is growing significantly. And that is because we are not hitting the tables to Sqlpass. We are just only going into the cache, we grabbing the number from the cache. So that makes it so incredibly fast. You see here that we just only have 30 accesses to the table itself. And that is a feature what I would strongly recommend to you that you don't disable it. Unfortunately, I see it so often because developers want to have ascending keys and there should be no value missing. Oh my goodness. So we have way more scalability in the system when you don't use it. But when I asked the developers, for what reason do you want to have it? It's just only a surrogate key. They said, yeah, they want to have it. It's the same as when you put flowers on a table and they have to look nice. That is exactly the same for them. So my recommendation is don't do that. If the developers do that for the future, for now, since SQL 2016, you don't have to disable it for your whole instance. You can put it on the database only, and that is way smoother than to disable it for the whole server instance. So yeah, that's it. And I think, yeah, I'm 7 minutes over. I hope you enjoyed it. The legacy cardinal estimator, you can replay it by yourself. Legacy cardinal estimation Long story short, if you're running SQL 2016, 2014 and newer, and you see that you have a degradation in your query because of the new cardinal estimation, then you can stop the new cardinal estimator in your database by setting the legacy cardinal estimation to on. So that's it from my side, and I hope that you have enjoyed so far my session. That I was showing you some interesting things, and yeah, and now I'm open for questions if you have.
Yeah, definitely enjoyed that session. Uwe, I got a question for AG with multiple secondaries, right? Can you
Yes.
set different DB scope values for each secondaries, or it's one for all secondaries?
That is a very good question. Let me show it to you. The question was, when you change for a database scope configuration setting, is it possible to have different settings for every secondary? The answer is unfortunately no. If you set for the customers for the database scope configuration, any database scope configuration, you can say here, just want to show it to you, you can only set it for the secondary in general, but not for saying, well, I want to have it this value on this one and this value on this one. That does not work, unfortunately not.
Yeah, definitely. This gives a lot of granular control for DBAs and for each database, right? For multi-tenant, yeah.
Yeah, so, to be honest, I am missing one database scope configuration. I'm really missing it, and I'm in discussion with Microsoft. We're from the MVP teams. We are sometimes talking to the optimizer guys and to Joe Sack and all these guys. And what I'm really missing is, you see here that we have the max stop. I'm really wondering why they don't have the cost threshold for parallelism in.
Yeah,
that is something I would love to have as a database scope configuration. Maybe in 2, 3, 4 years. So currently it's not in a plan, but I hope they will do it. They will implement it.
Yeah, great, awesome. Do you have any more questions? It's the best time to put it on the chat.
Yes.
And by the way, I already mentioned the link to the evaluation on the chat. If you guys have a few minutes, you can provide your feedback, ask more questions to Uwe regarding the session, or if you have any specific questions that apply only to you, then you can go ahead and put it on the feedback.
Yes, and by the way, so if you are too shy to put it on a chat, just drop me an email. I would really love to have an email from you. Don't worry about it. There is no stupid question. There could only be stupid answers. And I promise to answer really every single question. And I don't know if you're interested in the slide decks and in the demo databases. I can send you the links too.
Awesome. All right. I think that's... do you have anything to add before we wrap up?
Not from my side, no.
All right. So I think that's all for tonight, everyone. Thank you for joining us again, and watch out for the announcement for the next episodes. With that, thank you, Uwe. Thank you, Aroh.
You're welcome. It's a pleasure.
Thank you, everyone, for your time.
Thank you all. Bye bye.
Bye bye.